Hey everyone, and welcome back to Ever Wished You Had Just a Little More Time in Your Day? What if I told you that, scientifically speaking, some people on Earth actually do have slightly more time than others? And no, I'm not talking about daylight savings. Today, we're diving into one of the most mind-bending concepts from Einstein's theory of relativity, time dilation. It's the idea that time isn't constant for everyone. It can actually speed up or slow down depending on how fast you're moving or how strong the gravity is around you. Let's start with a crazy idea. Imagine two identical twins. One lives their whole life at a beautiful beach house by the ocean. The other spends their life in a cabin high up on a mountain. Now, you might think they'd age exactly the same, but according to Einstein, the twin at the beach will actually age ever so slightly slower than the twin on the mountain. Why? Because of gravity. Einstein's general theory of relativity tells us that massive objects, like Earth, warp the fabric of space-time around them. Think of space-time as a giant trampoline. A bowling ball placed on it creates a dip. The deeper you are in that dip, the stronger the gravity, and the slower time passes. Since the twin at the beach is closer to the Earth's center, they experience slightly stronger gravity. Now, before you pack your bags and move to the Himalayas, let me manage expectations. We're talking about an incredibly tiny difference. If you lived 80 years at the top of Mount Everest versus sea level, you'd only be about 0.001 seconds older. Not exactly a secret to eternal youth, but the principle is profound. But this isn't just theoretical fun. This is a real phenomenon that we have to account for every single day to make modern technology work. I'm talking about your GPS. Those GPS satellites orbiting Earth are experiencing two types of time dilation. First, because they're moving incredibly fast, about 14,000 kilometers per hour, special relativity says their clocks should run slower, about 7 microseconds slower per day. But then there's general relativity. Because they're far away from Earth's strong gravity, their clocks should run faster, about 45 microseconds faster per day. When you combine these two effects, GPS satellite clocks actually tick 38 microseconds faster than clocks on Earth every single day. 38 microseconds might sound tiny, but if we didn't correct for this, your GPS would be off by kilometers within a day. You'd be driving into a lake instead of to your destination. So, every time you use Google Maps, you're using a device that literally proves Einstein's theories of relativity. While these effects are subtle on Earth, they become incredibly dramatic in extreme environments. Imagine a black hole. Near a black hole, gravity is so intense that time slows down to an astonishing degree. For an observer near a black hole, minutes could pass, while for someone safely far away, years could go by. This isn't just sci-fi, it's the physics described by Einstein. It means that, in a way, time travel into the future is already happening for astronauts on the International Space Station. They return to Earth a tiny fraction of a second younger than their identical twins who stayed on the ground. So, the next time you're at the beach, take a moment to appreciate that you're experiencing time just a tiny bit slower than someone hiking in the mountains. It's a subtle reminder that our universe is far stranger and more fascinating than we often realize. What do you think about time dilation? Does it blow your mind as much as it blows mine? Let me know in the